Hey there, Mathinators. In this lesson, you will learn how to recognize an arithmetic sequence and find a given term in an arithmetic sequence. Some vital vocab we're going to come across. We're going to talk about sequences, terms, arithmetic sequences, and find out what a common difference is. Alright, so this is true. During a thunderstorm, you might have been told this before, you can estimate your distance from a lightning strike by counting the number of seconds from the time you see the lightning until you hear the thunder. When you list the times and distances in order, each list forms a sequence. A sequence is a list of numbers that often forms a pattern. Each number in a sequence is a term. So this particular sequence is listed here. So if 1 second passed between the seeing of the lightning and the hearing of the thunder, that means you are 2/10 away. 2 seconds, you're 4/10 away. 3 seconds, 6/10. 4 seconds, 8/10. And if you're 5 seconds pass, if 5 seconds passes between the lightning and the thunder, then you're a good 1 mile away. That's reassuring. So in the distance sequence, each distance is 2/10 greater than the previous distance. See how we added 2/10 to the previous term? When the terms of a sequence differ by the same non-zero number d, the sequence is an arithmetic sequence, and d is the common difference. The distances in the table form an arithmetic sequence with d equal to 2/10. Okay, so this is an example of an arithmetic sequence, and we know that based upon the fact that we're adding the same number to each previous term to get the next number. And that term, or that number rather, is the common difference. So the variable a is often used to represent terms in a sequence. The variable a sub 9 is the 9th term in a sequence. To designate any term or the nth term in a sequence, you write a sub n, where n can be any number. To find a term in an arithmetic sequence, add d to the previous term. Alright, let's make some sense out of that. So this is the formula for finding a term of an arithmetic sequence. A sub n equals a sub n minus 1 plus d, where d is the common difference, that number which we're adding to the previous term. Alright, so for example, if I give you this series of numbers, we're going to tell, first of all, is it arithmetic? Secondly, we're going to find the common difference. And then thirdly, we're going to extend this sequence 3 more terms. So it appears to go from 9 to 13, 13 to 17, 17 to 21. It appears that we're simply adding 4 each time. Well, the fact that we're adding the same number each time means this is indeed an arithmetic sequence, and 4 is the common difference. So now we can use that common difference to extend this sequence further by simply adding 4 to the terms already listed. 21 plus 4, 25 plus 4, and 29 plus 4. Thus, the sequence appears to be an arithmetic sequence with a common difference of 4, and the next 3 terms are 25, 29, and 33. Let's look at another example. Well, first, the 3 dots at the end of a sequence, oftentimes we just say dot, dot, dot. They are called an ellipsis, and that they mean that the sequence continues and can be read, and so on. So now you can say ellipsis. So determine if this is an arithmetic sequence, and then let's see if we can find a common difference. So how do we go from 8 to 10? I'm sorry, rather from 10 to 8, and then 8 to 5, and 5 to 1. Minus 2, minus 3, minus 4, that does not appear to be an arithmetic sequence because the common difference is not the same. So this is simply not an arithmetic sequence. Let's take a look at another example. Negative 3/4, negative 1/4, 1/4, and 3/4. Now don't get freaked out just because it's fractions. All the rules still apply. How do we go from negative 3/4 to negative 1/4? And likewise, how do you go from negative 1/4 to 1/4, or 1/4 to 3/4? In this sequence, we might want to look at the both positive numbers first. I know I add 2/4 or 1/2 to 1/4 to get 3/4, and that rule applies for these other terms as well. So you're adding 1/2 each time. The fact that we're adding the same number each time makes this an arithmetic sequence with 1/2 as the common difference. Now if we were to extend this sequence, we're going to simply add 1/2 to the previous terms. 3/4 plus 1/2. Again, we might want to think about this as 2/4 with a common denominator. 7/4 and then 9/4. It is arithmetic with a common difference of 1/2, and the next three terms 5/4, 7/4, and 9/4. Alright, you guys, you try. Now, see if this is an arithmetic sequence. Find the common difference, and then extend the sequence if you can. Pause the video now. Well, there you are. Okay, so I hope that you saw to go from -4 to -2, and -2 to 1, and 1 to 4, 1 to 5, that this indeed is not an arithmetic sequence. That's +2, +3, +4. There's no common difference here, so this is simply not an arithmetic sequence. So to find the nth term, that means the whatever term we're looking for of an arithmetic sequence, when n is a large number, you need an equation or a rule. We don't want to sit there and add the same common difference 30 or 40 times. That would be inefficient. So we're going to look for a pattern to find a rule for the sequence below. Let's see. These are our position numbers, and these are the term numbers. How do we go from 3 to 5, and 5 to 7, and 7 to 9? Well, if I let each of those terms be labeled accordingly, a sub 1, a sub 2, a sub 3, and so forth, then the nth position would be called a sub n. So this sequence starts with a 3. The common difference is 2, of course, because I'm adding 2 each time. So we can use the first term and the common difference to write a rule for finding a sub n. So in word form, this is what we've done here. The first term was 3, which is also called a sub 1. The second term can be found by taking the initial term and adding the common difference 1 time. The common difference being 2. Now where do we come up with that 1? Well, it's 1 less than 2, the second term. And the third term, initial term, plus 2 groups of the common difference. Why 2? Because 2 is 1 less than 3. Remember, the initial term is already, that's a term in itself, so that's 1 term, and then we need 2 more groups of the common difference. The fourth term, the initial term, that's 1 term, plus 3 groups of 2, for a total of 4 terms. So our formula, given the nth term, or looking for the nth term, is simply the initial term plus n minus 1. So whatever term we're looking for, we're going to take away 1. Why 1? Because the 1 is already taken by the initial term itself. So whatever term we're looking for, we need 1 less than that. And it's always going to be times the common difference. So this formula is what arises. A sub 1 plus n minus 1 times d. The pattern in the table shows that to find the nth term, add the first term to the product of n minus 1 and the common difference. So let's here's the formula in itself. A sub n equals a sub 1 plus n minus 1 times d. Let's put this to practice now. So we're going to find the common difference of these numbers given, and then we're going to find the 16th term. Now to go from 4 to 8, and 8 to 12, and 12 to 16, of course I'm adding 4 each time. So that's my common difference. And I'm going to try to write a rule to find the 16th term. So I want to find a sub n when a sub n is 16. So I'm going to sub in 4 for a1, sub 1. That's where we're starting. That's the initial term. 16 is going to be substituted in for n. That's the term that we're looking for. And 4 is going to be substituted in for d, the common difference. So a sub 16 equals the initial term 4 plus 16 minus 1 groups of 4. Looking for the 16th term, so it's going to be 16 minus 1 times the common difference. So now I can evaluate that, simplify the expression. 60 minus 1 is 15, times 4 is going to give me 60, plus the 4 that I started with gives us 64. So 64 would be the 16th term in this sequence. Let's take a look at another example. We're going to find the 25th term, where a sub 1 is negative 5 and d, the common difference, is negative 2. So the formula is given. I'm going to sub in negative 5 for a sub 1. I'm going to sub in negative 2 for d, the common difference. And we're going to sub in 25 for n, the term number that we're looking for. So a sub 25 equals negative 5 plus 25 minus 1. This is the initial term, plus 25 minus 1 groups of the common difference, which is negative 2. So we simplify that expression. 25 minus 1 is 24. Groups of negative 2 added to the initial term is going to give us negative 53. Negative 53 would be the 25th term in this sequence. Okay, you guys try. I'm looking for the 60th term in the sequence given with 11, 5, negative 1, and negative 7. Pause the video now. Okay, welcome back. So hopefully you solved the common difference to go from 11 to 6, 11 to 5, 5 to negative 1 to negative 7 is negative 6. Now it's okay, this is negative. Don't get freaked out because we've been adding numbers. We're simply adding negative 6 each time. Okay, subtracting 6 is the same thing as adding a negative 6. So it is still arithmetic. We're going to sub in to our formula, to our rule. A sub n, 11 is going to be a sub 1, our initial term. Negative 6 is going to be our common difference, and then we're looking for the 60th term, so we're going to sub in 60 for n. So I need 59 groups of negative 6 added to the initial term, 11, is going to give us, so everybody says, negative 43, negative 343 rather, negative 343. So that's finding various terms using the arithmetic sequence rule. Alright, so sometimes we have to find it in the context of a real-world problem. So in this case, a bag of cat food weighs 18 pounds at the beginning of day 1. Each day the cats are fed a half a pound of food. How much does the bag of cat food weigh at the beginning of day 30th? So I hope you recognize some of these ideas. The 18 pounds is going to be our initial term. The 1/2 pound per food is going to be the common difference. It's going to be negative 1/2 pound of food, or 5/10, because it's decreasing, and we're looking for the term, the 30th term. So since the bag weighs 18 pounds to start, a sub 1 is 18. We're going to want to find the weight of the bag on day 30. So we're going to need to find the 30th term. So I plug that into our rule. I'm going to substitute 18 for a sub 1, negative 1/2 for d, and 30 for n. And we can find that the bag of cat food weighs 3.5 pounds, remaining at the end of day 30. About time to buy some more cat food. Alright, you guys try this one, please. Pause the video now. Okay, welcome back. So each time a truck stops, it drops off 250 pounds of cargo. After stop 1, its cargo weighed 2,000 pounds. So how much does the load weigh after stop 6? So notice the sequence for the situation is arithmetic because it's changing by 250 pounds each time. So the 250 is decreasing, so it's a negative 250 is our common difference. The initial term is a sub 1 equals 2,000, and we're looking for the 6th term in the sequence. So we're going to use our formula. We're going to substitute our known values in for the variables. We're looking for a sub 6 once again. And we'll find that that truck weighs 750 pounds. That's the load of the truck, 750 pounds. Okay, in this lesson you learn how to recognize an arithmetic sequence and find a given term in an arithmetic sequence.